right, welcome to the second part of rationalizing. You can tell this is kind of a tricky subject, right? We were talking about how we don't want a radical on the bottom. Well, that's a relatively simple process, probably with the exception of the blue one. But within all of the red ones from last time, it's a relatively easy process to kind of get rid of that radical. However, when you have two things in the denominator, it's a little bit complicated. Okay, remember addition, subtraction, they never really play well together. So if you see a subtraction symbol down there, know it's going to take a little bit of an extra step. Now, you don't have to go back in your packet, but you can just check out the screen here. A little while ago, back in 8.2, I asked you to star a certain multiplication problem to look at it again when we got through to rationalizing. Pardon me, this is still 8.3. It was letter E. It had all these k's and radicals in there. Okay, notice what the final answer ended up being. There was no radicals in there whatsoever. Now, this didn't happen because of anything special. It was just a multiplication problem, but we can use this idea to help us now rationalize things. Notice how if you multiply by the exact same thing with the different symbol, what you get is the two front guys canceling each other out. I'm sorry, you get the two front guys canceling the radical part, and the two in the middle canceling each other. Very similar to when you had t plus 6, t minus 6, and you end up getting a polynomial that has nothing in the middle. All right, so we're going to kind of use this example here to solve our problem with this one here. If we look at this one, 5 over 4 root negative 3, 4 minus root 3. If I just multiply by root 3, right? Well, then yes, what happens is distribution. I do get a whole 3 here because I'd get 3 squared canceling with the square root, but on the other one, I get a root 3. And that didn't solve my problem. It just moved my problem. It moved it to the other term. So that's kind of frustrating. So what I need to multiply by is not just root 3, pardon me if you're working in pen. Instead, what I need to multiply by is a 4 plus root 3. What this will do is have that same thing that k and y had happened to them. So let's see what happened here. I got a FOIL, but I know 4 times 4. I'm going to move up a little bit, sorry. So 4 times 4 plus 4 root 3 minus root 3 times 4 and minus root 3 times root 3. And you see a lot of the same stuff, right? We get 16 here, a whole number, plus 4 root 3, still got a radical, but look at that matching opposite one. That might be helpful. And then 3 squared, we get a whole 3. So I have 16, cancel, cancel, minus 3. My denominator is now 13. A whole 13. It's been rationalized. Okay. Just like any other fraction, what we do to the bottom, we have to do to the top. So I'm going to multiply the top by 4 plus root 3. This one not nearly as bad because there's only one thing in the top, so I just do a little distribution. We get 20 plus 5 root 3. And really, at the end of the day, it may be worth your effort to distribute. It may not be. Sometimes 5 times 4 root 3 is okay as well. That would be our rationalized fraction. All right, let's do it again. So what do I need to multiply this by so that it becomes a whole number on the bottom? Well, I've got root 5 and root 3. You may be thinking, oh no, 2 radicals, got to be some crazy other version of this. Nope, it's the same thing. Minus root 3. In case you do remember this word, this term is called a conjugate, where it's exactly the same, but the opposite sign in the middle. Okay. This is called the conjugate. Let's go ahead and multiply those now. We've got root 5 times root 5. Maybe by now you're used to this, and you can see that that's going to be root 25. The next one is going to be negative root 15. Here we get positive root 15. And the last one we get negative root 9. Whoa, don't know what happened with my finger there. Okay, square root of 25 is 5. These two are going to cancel. And square root of 9 is 3. It looks like our denominator is a whole 2. Sweet. All right, up on the top, we have to multiply the same thing. And in this case, what would happen when we distribute? We get negative 24 times each of those. So I think it might actually be more in our favor to not do that, because then we could cancel these guys. We get negative 12 times the square root of 5 minus the square root of 3. and it actually reduces the fraction away entirely. So there's another benefit of rationalizing. It works the same with variables as well. And so we're going to do this the same. What's the conjugate here? Instead of 5m minus, I'm sorry, instead of root 5m minus root p, sorry, I didn't like the little blurb down here. I made a boo-boo. We're going to do plus root p. Cool. Multiply, multiply. Now, some math teachers really bank on you being able to go quickly. And in this case, you can kind of figure out what it's going to be. That's great. If you look at the first two, we had the square minus the square and the square minus the square. If you think you can do that here and you know the answer is going to end up being the square minus the square, awesome. You can kind of do that too. But remember, the more you try to remember tricks and stuff, the easier it is to mix them up. Okay, is it supposed to be plus, supposed to be minus, is it supposed to be like 5m squared? Like, what is it supposed to be? So instead, if you're worried you're going to mess those up, just do them together. Root 5m times root 5m is just going to be a whole 5m. Those, you get a 5mp. Here, you get a minus 5mp. And here, you get a minus p. Those will cancel. We end up with minus 5m minus p, just like we thought. All right, we do that to the top as well. Here, there is no benefit or disadvantage to multiplying that 3 in, so feel free to make it 3 root 5m plus 3 root p, or keep it outside. It doesn't cancel either way, and so it is entirely up to you. All right, next one. Last one, be careful here. Remember, rationalizing is a last resort. It is always a last resort to fix the problem. You always want to search for other things, but be very careful of your PEMDAS rules. Remember, this bottom it does have a subtraction in it, and so we cannot simply do that, unfortunately. It's like going like this. We can't do that. That makes no sense. You can't just divide out the 1 when you have 10 over 13. And that would be the same move here, where I'm dividing out the square root x and the square root x. They would be basically knocking off something you can't. And so we are going to have to rationalize here, but it's not too bad. Just do the opposite to both the bottom and the top. Okay, here we're going to have root x times root x. We get x. That's going to be plus 2xy minus 2xy and minus 4 root y squared, or 4y. So we get x minus 4y. And here is a perfect example of what I mean by being careful with tricks, because a lot of people would just say, oh, it's x minus 2y. You have to square that 2, because you see that on the end, that 2 times 2, I get a 4 there. The 4 is going to go with the y. And so again, be very careful of tricks. When we multiply this one, I recommend you multiply this one out, because if I do this one here, I get 3 times a whole x. On the second one, I get a 6 times a root xy. Again, I cannot cancel these two x's because they're both part of little mini expressions within a fraction, and I cannot cancel them. So I am finished. All right. That's rationalizing, where it's a bit more complicated. Again, if you have additional questions, reach out to your teacher. Otherwise, I will see you in 8.4 for an entirely different way to look at radicals. See you there.